So welcome for a math lesson. Today we are studying a mathematics topic called sequences and series, and we will start with sequences. A sequence is a regular arrangement of numbers following a certain rule. So for example, if we arrange numbers like 1, 2, 4, 6, you realize, okay, we can start from 2. 2, 4, 6, 8, 10. Those dots are meaning that the sequence is continuing. Therefore, from 2 to 4, there is an addition of 2. And from 4 to 6, there is an addition of 2 again. From 6 to 8, there is an addition of 2. From 8 to 10, again a 2 is added. So it means that if there is another term to be here, then it will be found by adding a 2 to 10, and it will be 12. Therefore, this sequence can be filled up to infinite number of terms. Therefore, the numbers in a sequence, we can note it. The numbers in a sequence are called terms. They are called terms. Therefore, examining this sequence, we can say 2 is a term in the sequence, 4, 6, and the others. So they are called terms. We should also note that a sequence is also known as a progression. It's also known as a progression. Therefore, we have two types of progressions, and the first one is arithmetic progression. We can abbreviate it as AP, arithmetic progression, or arithmetic sequence, because we've said a progression is also called a sequence. And the second one is geometric sequence or geometric progression, abbreviated as GP, geometric progression. You study each at a time, and you begin with arithmetic progression. Arithmetic progression, the AP. Therefore, we say an AP is a sequence such that a common difference is added to a term to get or to obtain the next one. For example, if we have 2, 4, for us to get 4, we added a 2. For us to get 6, we added a 2. To get 8, we added a 2. Therefore, in such a progression, whereby for the next term to be obtained, a common difference is added, we call it an arithmetic progression. So we say that now, the common term which is being added for the next number to be obtained, we call it the common difference. Therefore, we can say, can have this as a note, the first term in each or in a progression or in a sequence called or is abbreviated small letter a, and the common difference from a term to another is abbreviated small letter d. Therefore, given a first term, the first term, we have said it's abbreviated small letter a, and now the second term is obtained by adding a common difference d to the first term, so that we may obtain a second term. Again, to obtain a third term in a sequence, we add the same common difference to the second term. Therefore, with a plus, therefore adding d again, we will get 2d. For us to obtain the fourth term, we are going to take a, or we're going to take the third term and we add the common difference again. Therefore, adding the common difference d to the third term, we will have a plus 2d plus another d, we will get 3d for the fourth term. And for the fifth term, similarly, we shall have the fourth term, we add the common difference again. Therefore, a plus 3d plus another d, we get a plus 4d. Therefore, with that generalization now, we can say for a given sequence which is arithmetic, in nature, to obtain the nth term, we take the first term plus the nth term, where n is the position of that term, then we multiply by d. So we take the first term, then n minus 1 plus or multiplied by d. For example, the first term we said it is a. In the second term, we are taking a plus d, meaning that this is a plus, because n in the term here is the second one, we have 2 minus 1, then multiplied by d. So we'll have this one as 1 times d. We have it as d here. The third one, we will have a plus, this is 3 minus 1 into d. Therefore, 3 minus 1, we get 2 times d. We get 2d. The fourth one, a plus 4 minus 1, and we multiply d. So we will have this one as 3 times d. Therefore, the general formula is when we take the first term plus n, whereby n is the position of the term, minus 1 multiplied by d. Let me give an example. If you're told that given the sequence, 4, 11, 18, find part 1, the common difference, and part 2, find the sixth term. Solution to this question. We already have the sequence here from 4 to 11, from 11 to 18. Therefore, we can check from the first term to the second, what has been added? When we subtract 4 from 11, we are getting 7. We can check again. Between 18 and 11, we still have 7. Therefore, in this progression, it means a 7 is being added in each case. Therefore, we can conclude that the common difference is 7. Because from a term to the other, we are having 7 being added. Therefore, part 1 is solved, whereby we are finding the common difference in the given sequence. So 7 is the common difference. Then the second part, we are taught to find the 6th term. Remember, we had said that to get nth term, we take a plus n minus 1 into d. And now because this is the 6th term, then we shall get a plus n, 6th term, minus 1 into d. So in this sequence, first term, which is a, is 4 plus 6 minus 1 into d. Common difference. Common difference is found in Roman 1 as 7. Therefore, the 6th term will be 4 plus, this is 5 by 7. So this will be 4 plus 35, which is 39. Therefore, that's how we obtain the 6th term for such a sequence. Let me submit another example before we go to geometric progressions. Another one example. Okay, the question says, in an AP arithmetic progression, the 15th term is 52, and the common difference is 3, and the common difference is 3. Find part A, the first term, and part B, the 20th term. So we can have the solution to this question. We have said that nth term, this is a formula to be remembered, by A plus n minus 1 into d. Therefore, the nth term here, which is 15th term, is already given as 52, is equal to, the first term is not known. Remember, we are solving part A. The first term is not known, so we let it be A, plus, this is 15th term, so 15 minus 1 into the common difference, which is 3. It's given there. Therefore, 52 is equal to A plus 14 by 3. 14 by 3, is it 42? Yes. So we will have A as 52 minus 42, which will be a 10. So the first term in this progression is 10. Part B of the question, 20th term. Remember, nth term is given by A plus n minus 1 multiplied by d, meaning that for us to obtain the 20th term, we shall have the first term already calculated as 10 plus n 20 minus 1 into d, which is a 3. So this will be 10 plus 19 multiplied by 3. So 19 by 3 is 57, and 57 plus 10 gives us 67. Therefore, for that case, the 20th term will be 67. So with that now, I can leave you with a question to solve during your own time before I shift to geometric sequences. So a question to be solved later. So the question says the second term of an AP is, the second term of an AP is 7, and the ninth term 28, and the ninth term 28. Find the common difference in the first term. Find the common difference and the first term of the AP of the arithmetic progression. So that is it about arithmetic progressions. Now we can shift to part 2, geometric progression. Said it's GP. And in such a progression, this is a case whereby to obtain the next term, we multiply the given term. We multiply by a specific factor, which is called the common ratio. Abbreviated small letter r. Therefore, for geometric progression, to obtain the next term, you multiply the given term with a certain factor, and that certain factor is called the common ratio, abbreviated small letter r. For example, when we have 3, 9, 27, and such, you find the first term here is a, is 3. The a in this case is 3. And to get the next term, which is a 9, we've multiplied 3 with 3. So we have multiplied with 3. And from 9 to obtain 27, we have multiplied with 3 again. So to obtain another number here, it means we multiply by 3. Therefore, in this case, we have the first term as 3 and the common ratio as 3 also. Therefore, in a geometric progression, to obtain the next term, there is a certain multiplier which multiplies a term to get the next one. Unlike in the arithmetic progressions, whereby you are adding a common difference. Here we multiply with a given factor, which we're calling the common ratio. Therefore, I would like to give an example, and I believe you are going to understand it better. An example. If you're told, given the sequence, given the sequence 4, 12, 16, 4, 12, not 16, 36, then it continues. Find the fourth term. Find the fourth term. So we are going to find the fourth term in this case. Then now we will draw a conclusion and obtain a general formula to show how the next term in a GP is obtained. Therefore, solution, you can see from 4 has been multiplied by 3. And from 12 to 36, 12 has been multiplied with a 3. It means that from 36 to obtain the other term, which is the fourth term, then we will still multiply by a 3. 36 by 3 will give us 108, which is the next term and the fourth term for that matter. Therefore, in a geometric progression, the first term is always A. And to get the second term, we multiply A with a given ratio. We're calling it R. From the second to get the third term, we multiply the second one with the same ratio. Therefore, A times R already, we multiply by R again. So it becomes now by R squared. To get the fourth term, we take the third one and we multiply it with the same common ratio. Therefore, it will be A. It is already times R squared. To get fourth term, we multiply again by R. So now it becomes R cubed. From the fourth term to get the fifth, we multiply the fifth term again with the same common ratio. Therefore, it will be A, because R is already cubed. When we multiply with R again, we get R power 4. Therefore, generally we can say the nth term in a geometric progression is given by when we take A multiplied by R raised to power n minus 1. Therefore, if it is the fifth term, we get the first term times R raised to power 5 minus 1, which is 4. Fourth term, A multiplied by R raised to because it is 4 minus 1 becomes 3, and such. So to obtain maybe a sixth term, it will be A times R raised to, because it is sixth term, we will have 6 minus 1, meaning A times R raised to 5. So that's how we obtain any other term in a geometric progression. Let me give an example. So an example here says, the fourth term of a GP is an example. The fourth term in a GP is 16. If the first term is 2, if the first term is 2, find part A. Find part A, the common ratio. And part B, the seventh term. Solution. So we are given the fourth term of a GP as 16 and the first term is 2. Find common ratio, and part B, find the seventh term. Therefore, we know that the nth term is given by A, R raised to n minus 1. So in this case, we have the fourth term which is given as 16, should be given by the first term, which is already given as 2, multiplied by r. And we don't know the r, but we know it will be raised to, because n is 4, the fourth term, we'll have 4 minus 1. Therefore, this 16 equal to r cubed. So we can remain with r cubed on this side by dividing through by 2. Therefore, dividing through by 2, we'll have r cubed, and this becomes 8. So now to obtain r, because this is r cubed, it means we will take the cube root of 8. Therefore, the cube root of 8 is 2. So r in this case is 2. The common ratio will be 2. Part B, find the seventh term. Therefore, to obtain the seventh term, it means we will take the first term, which is given here as 2, times r. R we've already calculated in part A. We have found it is 2. Then r we raise it to power 7 minus 1. So this will be 2 times 2 raised to power 6. It will be 2 times 2 raised to power 6 is a 64. So 64 by 2 is 128. So that will be the seventh term for this geometric sequence. So that's all about geometric sequences. In the next class, we'll be doing series. So thank you very much for following. Kindly subscribe to Shifting Grades. Share our link with your friends.